Hello dear students, welcome to YouTube channel Learn with Gizla. In this video of polynomials, we shall be learning how to use algebraic identities to factorize quadratic polynomials. So let's get started. Now polynomials can be factorized using algebraic identities. Now what are algebraic identities? That I have already explained in the previous video. You can check out the link in the description box. Basically, algebraic identities are statements of equality which hold true for all the values of the variables which occur in that algebraic equation, right? They hold true for all the values. Whatever you put the value of any variable, it will come true. That means the left hand side will be equal to right hand side. Now a polynomial having degree 2 is called quadratic polynomial. That means the highest power of the variable in these polynomial is 2. Therefore the degree is 2, hence they are called quadratic polynomials, and they can be factorized using these 5 identities, right? I have already discussed in the previous video, so you can check out from there. Now let us take some examples of how the algebraic identities can be used to factorize quadratic polynomials. Now the first identity says that x plus y whole square is equal to x square plus 2xy plus y square. X plus y whole square means what? That you are multiplying two factors x plus y into x plus y, yes, and you are getting a product which is equal to x square plus 2xy, right, plus y square. This is your product. So every question is in the form of a product, right? It's a quadratic polynomial, which is, you can say, it's a product. Now you have to factorize it. That means find its factors. It is same way as suppose a number is there 35. I say factorize it. So you will say its factors are 5 into 7. Right. In the same way, this is the product given and we have to factorize it. That means we have to find its factors in the form of x plus y into x plus y. Right. Now this is first identity. If you see, there are two square numbers. Right. So if you compare it with the question, we have 4a square and 9b square, which is also a square number, of 2a whole square and 3b whole square. So clearly over here we can say x is equal to 2a and y is equal to 3b. Right? This is understood. Now in between we have 2 into x into y. So 2 into 2a into 3b. Exactly the same identity we are using over here, identity 1, where we are just splitting this 12ab according to this identity 2 into x into y. That means 2 into 2a into 3b, which is actually, if you observe, 2 into 2 4, 4 into 3 12 into ab. So it is 12ab only, which we have split it according to match the product in the identity given. Now when this product is like this, so its factors are x plus y whole square. And what is your x? X is 2a, y is 3b. So can I say the factors are 2a plus 3b whole square? Right. So this is how we have factorized it. Now let us move to second identity. Second identity says x minus y whole square is equal to x square minus 2xy plus y square. If you observe, what is the difference between first and second? Both are whole numbers. Again, the only difference is with the plus and the minus with the middle term. Middle term is 2xy. Right. Now the question is in the form of the product, right? 9x square minus 24xy plus 16y square. Let us write in this form of identity. So both are square numbers. 9x square and 16y square are square numbers. So which we can write as 3x whole square, 4y whole square. In the middle we have minus 2 into x. Now x is what? Again, x is over here. If you compare it, x is your 3x. And y is what? Y is your 4y, right? So 2 into x into y will give you 2 into 3x into 4y, right? Which is nothing but minus 24xy, because 2 into 3 into 4 is 24. 24 into xy, right? It is nothing but we have just split it and wrote in the identity form. Now the identity says if the product is this, the factors are x minus y whole square. That means both are negative. Both the factors are negative. In identity 1, we have both the factors positive. Over here, we will have both the factors negative. So we have x, that is 3x, and y, that is 4y. So x minus y will become 3x minus 4y. So there are two factors to it. What are those two factors? 3x minus 4y. Yes, multiplied by 3x minus 4y. So instead of writing 2 times, we just write whole square, right? So this is another second identity which we have used to factorize quadratic polynomial with a minus sign in the middle term. When it is plus sign, we will use identity 1. When it is minus sign, we will use identity 2. Now comes identity 3. In identity 3, we have of the form x square minus y square. This is the product, and the factors of it are x plus y and x minus y. That means when we don't have any middle term, we have two square numbers, and the difference of these square numbers is equal to the product of the factors which are x plus y and x minus y. One is plus, one is minus, right? So let us take a question. The question says x square minus 4y square. Both are square numbers, which we can write as x whole square, and 4y square can be written as 2y whole square, in between minus sign, right? So basically difference of two squares. So its factors are, so over here if you compare, first of all let us compare what is your x and what is your y. So if you compare this, your x is x and your y is, if you compare these two, your y is what? 2y. So the factors are x plus y into x minus y. So x is x. So x plus 2y, x minus 2y. One is plus, one is minus, right? So in identity 1, both were plus plus. In identity 2, both the factors were minus minus, right? Both the factors were minus minus. Over here in identity 1 is plus, 1 is minus in identity 3. Okay, and there is no middle term. There are only two terms in the product, right? So the factor will have 1 plus, 1 minus, right? Now let us come to identity 4. According to identity 4, if our factors are x plus a into x plus b, the product is x square plus a plus b into x plus ab, right? This is the identity. Over here, these are the factors, right? These are the factors, and this is the product which we get after multiplying, right? This is actually the identity. But over here, since we have to factorize a quadratic polynomial, the quadratic polynomial will be in the form of ax square plus bx plus c, right? Now, which is equal to whose factors which we will find will be x plus p into x plus q. So the quadratic polynomial, the product now will be this, right? And the factors which we will get will be this. Now you will say there is a difference between this product and this product, right? Actually it is same. See, when you open this bracket, you will get ax plus bx. In the standard form, they are taking it as one term bx, right? They are just changing it to bx. And ab, the product which is over here, they are taking it as a c, right? This is the only difference. Otherwise it is same. So this is the product, these are the factors. Of course, because we have used ABC over here, so in the factors we are using the alphabets P and Q. So how to go about with it? How to factorize the quadratic polynomial which is of the standard form ax square plus bx plus c. So first of all, if it is not in the standard form, we will make it into standard form ax square plus bx plus c. Identify what is our b, what is our a, what is our c, right? And now after identify a, b, c, we will find two numbers p and q such that p plus q will be equal to b, and pq, the product of these two numbers, will be equal to the product of a and c. right? So such two numbers we will find. After finding P and Q, naturally this Bx, which is in the middle, will be split into two. Bx we are going to split as Px and Qx, right? We are going to split it, right? As it is shown in the original identity, a plus b into x na, and I told you that this bx they have taken in the standard form. So this bx now will be split into two, which we are now calling it as px and qx, right? And after splitting into two, now we will take common terms, right? Like over here we can take x common, so ax plus p will be left inside, and over here we can take q common with the plus sign, sorry, outside, q common, and then x plus p will be left inside, right? And further we will see that what can be taken common outside. X plus p and x plus p generally we will get over here, and then x plus p common and x plus q. So basically we will get two factors. If we are assuming a to be 1, so we will get x plus p as one of the factors and x plus q as one of the factors when a is 1 over here. Okay. So this is how we are going to solve it. Factorize the quadratic polynomial. Let us take an example. So we have to factorize x square plus 2x minus 15 and 6x square plus 7x plus 2. These are the two examples which I have taken. Let us start. So first one is x square plus 2x minus 15. Over here, what is your a over here? If you compare it to the standard form, what is your a? A is your 1, b is your 2, and c is your minus 15, right? Now you have to think of two alphabets, you can say two variables, p and q, such that their sum is b. B is 2, right? B is 2. And their product is a into c. And what is a? 1, and c is minus 15. So pq should be 1 into minus 15, that is minus 15. Now factorize 15. Suppose you factorize 15. What do you get? 3 into 5. Yes. Now you want minus 15 also. At the same time you want their sum to be plus 2 also. So can I say 5 minus 3 is equal to 2, and 5 into minus 3 is equal to minus 15, right? So like this, in this way, by trial and error method, you have to find such two numbers p and q, right, whose sum is b, that is 2, and the product is ac, that is minus 15. So clearly those two numbers are 5 and 3. See, 5 minus 3 is 2, and 5 into minus 3 is minus 15. Now split bx, the middle term. What is bx? That is 2x. So this 2x now we will split into 2. What are these two terms? 5x minus 3x. So we are splitting it, right? We are splitting it over here, right? Now group them. After splitting, now as I told you, you have to group them and then take the commons. Okay. So we will take the pairs x square plus 5x and minus 3x minus 15. Plus I have taken in outside. So minus 3x and minus 15. Now in this group, in this pair of terms, we can take x common. So x common, x plus 5 inside, minus 3 common outside, and x plus 5 inside. Now x plus 5 and x plus 5 are common, which we can take it outside. From here we are left with x, from here we are left with minus 3. So x minus 3. Clear? So x plus 5 and x minus 3 are the two factors of this given quadratic polynomial. Now how to identify whether we have to use identity 4 or identity 1 and 2, because this can be identity 1 and 2 also. Yes, it is not identity 1 and 2 because there is only one square term. This term is not a square number, right? Whereas in identity 1 and 2, we had two square numbers. In identity 4, we have only one square number. As you can see over here also in the question, 6x square, right? This is not even a square number. This is not even a square number. So in identity 4, though there are 3 terms, it may or may not be a square number, right? So that is the only difference between 1 and 2 and the fourth identity. Little confusing it is, but with practice you will come to know. Of course, when we have two square numbers, so it can be identity 1 or identity 2, depending on the minus sign of the middle term, right? Let us take another example. Now we have 6x square plus 7x plus 2. Now over here, if you compare it with the standard form, ax square, that means 6x square. So a is 6, bx, that is 7x, that is b is 7. Now c is plus 2 over here, right? So a, b, c are identified now, right? Now you want two numbers such that p plus q, whose sum is b, that is 7, and p into q is a into c, that is 2 into 6, which is equal to 12. Now factorize 12, either you can have 6 into 1 or you can have 3 into 4, right? I think 3 plus 4 you will get 7, and 3 into 4 is 12, right? So these are the two suitable p's and q's, right? Their sum is 7 and their product is 12, right? So the middle term 7 x can be split into 2, that is 3x and 4x, right? And further we will group. So here we have split them, 6x square, 7x is been split, 3x plus 4x plus 2, right? Now group them, make pairs and take x or whatever common is there. Over here 3 is also common, so 3x common. Inside we are left with 2x plus 1, and over here in the next pair we have 2 common and we are left with 2x plus 1. Now 2x plus 1 is over here, 2x plus 1 is over here. So 2x plus 1 we have taken out common. From here we have 3x plus 2, 3x plus 2. So these are the two factors which we got of this question of ours, quadratic polynomial, which we had to factorize, right? Now let us learn how to use identity 5 in factorizing quadratic polynomials having 6 terms. Like in this question which I have taken, there are 6 terms. So how to use identity 5 in solving them? So over here identity 5 says that whenever you have two factors like x plus y plus z into x plus y into z, that is a trinomial, right? Then the product is x square plus y square plus z square plus 2xy plus 2yz plus 2zx, or xz we can write. It means the same, z into x or x into z. So whenever we have a product like this, right, in the question, and we have to factorize it, so we will have to identify what is the x, what is the y, and what is the z. And accordingly, according to the signs which are used in the product, we will have the plus and the minus in the factors, and we will get the factorize, and this is how we are going to factorize. So let us start with the question. We have 4a square plus 9b square plus c square. If you observe, these first three numbers are a square number, and next are 12ab plus 6bc plus 4ac. Now we have to compare this first three terms of the product with the first three terms in the question to identify what is your x, y, z. Okay, and need not bother about the sign because here all are plus terms, so it's okay. So now 4a square is nothing but 2a whole square, 9b square is nothing but 3b whole square, and c square is nothing but c whole square. So all are square terms where x, you can say it is 2a, y is your 3b, and z is your c. So that means x is now has come 2a, y is 3b, and z is c. Accordingly, now further if you expand it according to the identity 2xy, it says the product should be 2xy. So 2 into x, x is 2a, b is 3b. So 2 into a into, sorry, x into y. Now see, 2 into 2, 4. 4 into 3, 12. Isn't it 12ab over here? Right. So what we have done, we are splitting it. splitting the terms in such a way that we are getting 2xy. Now next term 6bc. 6bc can be split as 2 into y into z. So this is your 2, this is your y, and this is your z. Over here this was 2, this was x, and this was y. So now y is 3b, c is your z. Yes, so accordingly if you see 2 into 3 is 6, b into c, bc, bc, now 6bc. We have split like this. Now next is 4ac. Let us see how to split it. So isn't it 2zx or 2 into x, 2 into x into z, right? X is 2a, z is c. 2 into 2 is 4, 4, and a into c is ac. So 4ac. So 4ac has been split over here, right? So if you observe, this is your 12ab, this is your 6bc, and this is your 4ac, right? Now the identity says whenever you identify your x, y, and z, then your factors are x plus y plus z whole square. Now put them in the identity. X is 2a, y is 3b, z is c, and whole square. So this is your answer, right? So the two factors are 2a plus 3b plus c into 2a plus 3b plus c, or you can just write it as whole square, right? Now let me take a question where minus sign is also involved. Now this question has minus sign in the terms minus 12ab and minus 6bc. Now of course these first three terms will not have a minus sign. Why? Because these are square numbers, right? 4a square is 2a square, 9b square is minus 3b whole square, c square is c square. Now why this minus I have written, I'll explain. Because these two terms have b common. That means b is the culprit who is making these terms minus, right? So b is the negative term who is turning these terms negative. So minus will go with your this minus 3b, or you can say y. Yes, if you compare it with the identity, this is your x, this is your y, and this is your z. So b is over here, b is the common term over here. So b is negative, that means your y is negative, that means minus 3b is negative. Right. So from these three terms, so we got the square number. X is 2a, y is minus 3b, and z is c. Right. Further, you expand minus 12ab. So first write down plus sign, because our identity has plus, you write down plus. Then 2 into x. This is our x. This is our y. Y is what? Minus 3b. Okay. Automatically you will get minus 12ab. When you solve it, plus minus minus, 2 into 2 4, 4 into 3 12, minus 12ab already you have got it, right? But keep plus sign outside because our identity has plus. If you don't keep plus over here, then you will get wrong answer. Now over here 2 into y into z, right? Then over here 2 into x into z, right? So accordingly we have put the value. So the identity says whenever you have such product, the factors are x plus y plus z whole square. Now put them in the identity in the factors. 2a, now plus y and y is minus 3b. So plus into minus minus, minus 3b plus z, z is c. So this is your answer. These are the factors. Whole square itself means that you are multiplying the trinomial twice. Yes, you are multiplying it 2 times. So 2a minus 3b plus c into 2a minus 3b plus c. You are multiplying it 2 times. Right? So this is it, children. Hope you have understood how to use algebraic identities to factorize quadratic polynomials. Thank you, children. Have a great day ahead.